I had problem number 4, which was write an equation for the linear function f satisfying the given conditions. So the function of -3 would be 4, and the function of 1 would equal 1. The first thing I'm going to do to get the equation is solve for the slope. So what I'm going to do is take one of the y values. I'm going to choose 4, and then subtract it from the second y value, which is 1. So I'm going to do 4 minus 1 over -3, the x values minus the x values. So -3 minus 1. This is going to give me a slope of 3 over -4. Now that I have the slope of -3/4, I have two options. I can figure out the equation by using point-slope form, or I can figure out the equation by using slope-intercept form. I'm going to start out by using point-slope form to get the equation. So what I'm going to do is put y minus y1, which is the easiest case to plug in 1 and 1. So I'm going to do y minus 1 equals -3/4, my slope, times x minus 1. After I did that, I'm going to distribute this one out. So y minus 1 equals -3/4 x plus 3/4. Then once I did that, I can add 1 to both sides. This leaves me with y equals -3/4 x plus 7/4. The second way to solve this problem would be by using slope-intercept form, which is y equals mx plus b. So once again, we're going to plug in a set of our values, and I'm going to use 1. So 1 equals -3/4 times 1 plus b. So we're solving for b, which is the y-intercept. After we simplify this part out, we get 1 equals -3/4 plus b. Then we add 3/4 to both sides. And get 7/4 equals b. Once we know what b is, we can write the equation in slope-intercept form, which is y equals m, which is the slope, so -3/4 x plus 7/4. The next problem that we have is problem number 22, which is to graph the function. We have the following function, and the first thing we're going to do is see where the graph crosses the x-axis. To do that, we're going to set each of these factors equal to 0. So when we set x minus 1 equal to 0 plus 1, x equals 1. So this is going to be one place that the graph could cross the x-axis. And then after that, we're going to try to solve this one, which is x plus 3 equals 0, subtract 3, subtract 3. So x equals -3. Another place that the graph could cross the x-axis. So we could put a 1 above here, since it has a multiplicity of 1, which is an odd number. We know that at x equals 1, the graph is going to go through the x-axis. Whereas where here we have an even multiplicity, we know that the graph is going to bounce off of this point. Since we know that the degree of the polynomial is odd, because 1 plus 4 equals 5, and 5 is an odd number, we know that the graph is either going to do something like this, or like this. The graph will look something like this because the leading coefficient is positive. This is a positive graph, and we could insert a 1 here if we wanted to. Okay, now taking my information that I solved in the first part of this problem, I'm going to graph the equation. So I know that it's going to look something like this, and I also know that it's going to go through 1, and it's going to bounce off -3. So I'm going to go to -3, and I'm going to make it go up like this, bounce off, then find 1, which is here, and go all the way through it. And there's my graph. Another way that I could have solved this problem was to type it into my graphing calculator. So what I would do is go to y equals, and then type the equation in, which is x minus 1, close parentheses, x plus 3, close parentheses, to the power of 4. After that, I'm going to hit my graph button, and we'll look at the graph. After that, I would copy the graph down onto my graph paper.